first technique for integration is integration by parts. And our first example is the integral of x times e to the 5x dx. And to find this, we are going to use the reverse product rule, which is shown here. So the second step is to find the f of x and the g prime of x in the equation. And f of x for this equation is x, and the g prime of x is e to the 5x. And from there, you can use it to find the f prime of x and g of x. F prime of x is 1, and g of x is 1/5 times e to the 5x. And then step 3 is you plug it into the equation. So step 4 is to simplify, and the answer you would get is the integral of x times e to the 5x is equal to 1/5 times x times e to the 5x minus 1/25 times e to the 5x.
Here's another problem that can be solved using the integration by parts technique. Example 2 is the integral of ln x times 1. Step 1 is to label each function. From the given problem, we know that f of x is ln x and g prime of x is 1. And using these two values, we can also find that f prime of x is 1 over x and g of x is x. Step 2 is to plug in the values defined in step 1 into the reverse product rule equation. Doing this, we get ln x times x minus the integral of 1 over x times x dx. And step 3 is to simplify, and this results into x times the natural log of x minus x plus c.
Our second technique of integration is called integration by partial fractions, and the integral that we are going to evaluate is the integral of x minus 1 over 2x plus 5 times x minus 8 dx. So the basic principle of this idea is that you can rewrite this integral as a over 2x plus 5 plus b over x minus 8. In order to add these fractions together, you're going to want to get common denominators for both the fractions. So basically, you are just going to multiply by the denominator of the other fraction. So you get a times x minus 8 over 2x plus 5 times x minus 8 plus b times 2x plus 5 over 2x plus 5 times x minus 8. Now that both of these fractions have common denominators, you can add them. And the next thing you want to do is distribute. So you are going to multiply out a times x minus 8 and then b times 2x plus 5. So you have a simplified version of your numerator over the denominator. So in the original integral, the numerator is x minus 1. So you want to get your numerator of your new fraction in a similar format. So you will take out the x to get x times a plus 2b minus 8a minus 5b. And so you can set your first part equal to x minus your second part equal to 1 over the original denominator. Now that you have set each section of your numerator equal to the first part equal to x, the second part equal to 1, you can use a system of equations to solve for a and b. So when you solve, you get a equals 1/3 and b also equals 1/3. Next, you will plug in your a and b into the original fractions we had. So you basically have the integral of 1/3 over 2x plus 5, which originally was a over 2x plus 5, plus the integral of 1/3 over x minus 8, which is equal to b over x minus 8. From there, you simplify, so you can take the 1/3 out of both of the integrals and then solve as you normally would to get your final answer of 1/6 natural log of 2x plus 5 plus 1/3 natural log of x minus 8 plus c.
So our second example for integration by partial fractions is the integral of x minus 3 over x plus 4 times x plus 5 dx. And the first step is to write them as fractions, so they would be a over x plus 4 plus b over x plus 5. The second step is to find the common denominator of the fractions. So it would come out as a times x plus 5 over x plus 4 times x plus 5 plus b times x plus 4 over x plus 5 times x plus 4.
Once you have achieved common denominators, you're going to simplify the fraction, and you're going to multiply a times x plus 5 to get ax plus 5a, and then you're going to multiply b times x plus 4 to get plus bx plus 4b. We forgot to write the b, So once you have multiplied out your numerator, you are again going to factor it into two sections written just like the original numerator in the original integral. So you're going to have x times a plus b, set that equal to x minus negative 5a minus 4b, and that is going to be set equal to 3.
Step 5 is to solve for a and b. Using the factors defined in step 4, we created a system of equations where we found that b is equal to 8 and a is equal to negative 7. Step 6 is to plug a and b into the fractions, then we'll get the integral of negative 7 over x plus 4 plus the integral of 8 over x plus 5. Finally, in step 7, we integrate and simplify. Since negative 7 and 8 are constants, they can be pulled out of the integral. Then we integrate the fractions. Finally, the solution to this problem is negative 7 times the natural log of the absolute value of x plus 4 plus 8 times the natural log of the absolute value of x plus 5 plus c.